Good morning, Internet. My name is Jack C, and today we will be looking at a new paper from DeepMind called Reinforcement Self-Training for Language Modeling. A while ago, OpenAI released a paper that proposed an approach called reinforcement learning through human feedback. This is to fine-tune GPT-3 models to follow a broad class of written instructions. This technique uses human preferences as a reward signal to fine-tune the large language models. It uses online reinforcement learning, such as proximal policy optimization (PPO), as the reinforcement learning algorithm to update the policy language model. However, there are problems with such approaches. Online reinforcement learning requires sampling from the updated policy and scoring the samples with the reward model a lot of times during the training process, and it is prone to reward hacking. In the meanwhile, offline reinforcement learning methods depend on the properties of the offline dataset. Carefully curated datasets become very important for the success of offline reinforcement learning. In this paper, DeepMind proposed a method called Reinforced Self-Training Method, REST. It is a type of growing batch reinforcement learning algorithm that aligns the large language model's outputs with human preferences as a replacement for PPO. This method uses an inner loop, the improve step, and improve the policy on a fixed dataset. In the meanwhile, in the output loop, the grow step, it grows the dataset by sampling from the latest policy. REST is computationally efficient compared to online reinforcement learning. Its quality of policy is independent from the quality of the original dataset. It is interpretable and allows us to mitigate any data quality and alignment issues. And it provides stable training with minimal number of hyperparameters. Here is how REST works. We start off by training an initial model, pi, to map input sequences x to output sequences y on the given dataset of sequence pairs d using the negative log likelihood laws. Afterwards, we execute the growth step. In this step, we generate a fresh dataset, a new dataset, DG, by expanding the original training dataset with instances generated by the model. This is achieved by generating multiple output sequences using the current policy pi. The newly generated sequence dataset is then evaluated using a reward function called R. Instances that receive a reward surpassing a certain threshold are employed to update the policy. As the policy gets enhanced, a new collection of higher quality samples can once again be generated. Ultimately, during the improved step, we evaluate and refine the expanded dataset using a scoring function. This function is driven by a reward model derived from human preferences that we have. Subsequently, the language model undergoes fine tuning based on the refined dataset, guided by an offline reinforcement learning objective. This process can be iterated with an increasing filter threshold. The resulting refined policy is subsequently applied in the subsequent growth step. Following multiple iterations, we will attain our ultimate optimized policy. They tested the performance of REST in multiple machine learning translation using the following large translation datasets from English to other languages. There are quite a lot of figures in the paper, but this is the most interesting one. This figure right here shows the average reward score for the reinforcement learning algorithms. It appears that REST outperforms the existing methods such as PPO and BC in machine learning translation from German to English. More interestingly, we also see that it's possible to increase the reward score significantly just by increasing the number of grow and improve steps. Overall, while REST is proven to be useful in language modeling, I do think that this approach could also be useful for other machine learning generation tasks, such as image generation and molecular generation as well. There are a lot more stuff in the paper that I did not go through, but I would like you to check out the paper for yourself. Anyway, that is all, folks. Thanks for watching, and don't forget to like, comment, and subscribe, and I will catch you all in the next one. Cheers.